Hello, I'm Sean Powers. Welcome back to the Ubuntu Server Series. This nugget is about SSH, my absolute favorite SSH. My favorite H, my favorite protocol, my favorite program. SSH is awesome. It stands for super, super awesome, which is an A, so we'll say it's a silent H. Super, super awesome. And that's not actually what it stands for. But SSH is so powerful, you can use it every single day you're on a Linux box. And if you're a Linux user, especially if you're a sysadmin, you will. So let's learn about some of the things you can do with SSH. And I know that it's the Ubuntu Server series, so we're going to talk a little bit about specifically how Ubuntu handles SSH. But I just can't help myself. I got to talk about some of the cool things you can do with SSH regardless of the operating system or distribution that you're using. So let's get down to business because I got a lot of stuff I want to cram into this nugget. Let's go. So all joking aside, SSH stands for Secure Shell. So the SH here is in shell. So secure shell. And it's a way to remotely access the console or the shell of your Linux server. Every Linux system, whether it's server or desktop, has a shell, and you can install SSH as the server and client on any Linux machine. These are the main topics that we're going to cover in this nugget. Passwords and key pairs. This is kind of vital if you're going to, well, it's very vital if you even want to use it at all. You have to log in with passwords the first time. But key pairs are a way to add a different type of security to an SSH connection. We're going to talk briefly about X11 or X Windows forwarding. This isn't something I use all the time, but it's just a really cool thing. So I like to show how to do it. And every once in a while, there is a use case where it's very, very useful. TCP forwarding, this is complex. This is a little bit hard to wrap your head around. So we're going to spend a little bit of time here so that conceptually you get what's going on. There's two different kinds of TCP forwarding or tunneling. It's forward in reverse. We're going to talk about both, and hopefully my pictures will be good enough that you'll understand. Then the SOCKS proxy. This is along with X11 forwarding. SOCKS proxy is one of those things that you don't necessarily use all the time, but it's pretty cool, and it's a nice way if you're at a coffee shop to protect your traffic. And then, remember I said we're going to talk about the Ubuntu specific stuff. That's where configuration comes into play. So if you're here just because you only want to know about Ubuntu and only things that have to do with Ubuntu, skip ahead about 18 minutes because we're going to talk about this for quite a while. But anyway, these are the topics we're going to cover. Let's start with passwords and key pairs so we understand what they are, and then I'll show you how to manipulate them and bend them to your will. So basically here we're talking about authentication. Authentication, how you log into a remote system with that secure shell. You've seen me use SSH in lots of times in this whole series, and almost every time, except for one that I'll talk about in a second, we've used passwords. So this just means you connect to it. It says what's your login, what's your password, and you log in using the credentials that you have on the system. So this is one way and the default way to authenticate to an SSH server. Nothing wrong with this. This is how you get into servers. This is how you get into computers all over. This is a very common, probably the most common way to authenticate to a server using SSH. There is another way. There is another way. And that is to set up a key pair. Now, if you're not familiar with the concept of public and private keys, here is my 2-minute, let's see if I can do it in 2 minutes, explanation. Basically, a key pair means that you have two chunks of encrypted data. You have a public key, which for our demonstration, we will say is a lock. So this is the public key. And I know it's called key, so that makes my illustration here a little confusing. But this is the public key, which for our case is represented as a lock. And then an incredibly ugly private key. So we have these pairs. We've generated this key pair. These only work with each other. Now, the private key, as you can imagine, we want to keep private. Only I have this, right? It's only on my computer. I'm the only one that has the private key. And this private key will unlock anything that is locked with my public key or the lock. So I can have copies of this lock everywhere. I can put a copy of this lock on my shed. I can put a copy of this lock on my refrigerator. And only me with my private key that nobody else has access to will be able to take that lock off. So this works for messages. If somebody sends you an encrypted message, if they lock it or encrypt it with your public key, remember the public key is like a lock. If they encrypt it with that, nobody is going to be able to unlock that and read it unless they have your private key, which will unlock this. It doesn't matter who has a copy of your public key. It does not matter, because all they can do with it is encrypt it so that only you can get it. Now, it gets more complex with signing back and forth and make sure that it's from the original person, but for our intents and purposes today, the first level entry into public key pairs, public and private key pairs, is just that. This public key can be everywhere. Anybody can see this. There's no need to hide this at all. In fact, a lot of people hide or put this right in their email signature, right? A long string of text that's their public key. Anytime somebody wants to lock something that only you can get to, they use that. And that is exactly how key pairs work. Now, to add a layer of security or another layer of protection, key pairs can be password protected. So that basically means that in order to use my private key, I have to have the key, which in my case is a digital hunk of data. But I have to have this private key, and I have to know the combination of the password. So we'll say like the private key has like a combination lock on it, that I have to know the combination to even use the key. Now, a lot of times, and most times, to be quite honest, usually we use key pairs on a Linux system to log in so that we don't have to use a password for authentication. So it's possible to have an empty passphrase. That doesn't mean it's unsecure, because you still have to have the private key to get in. However, it won't prompt you for a password to use the private key if it has an empty passphrase. This is very useful if you want something to log into a system unattended, like in a script. And I say it can be a security risk, because if somebody gets a hold of your private key, they have full access to the system that you're using key pairs to log in with. So hopefully that makes sense. Now, why would you want to password protect a key pair if you can just use password authentication? Well, the reason is, usually when key pairs are used for secure logins, passwords are disabled. So the only way to get in is to use a key pair, and then if that private key is password protected, then you have to have both a password and a private key to even log into the system. So that's the way to be super secure with key pairs. But generally, when we talk about server administration, we do this fancy trick where there's no passphrase, but we have to use that private key to log in. And you just keep this private key. Man, you never want to let your private key out, right? It's very, very, very important that nobody gets a hold of your private key, because then they can unlock any locks or any systems that you have secured with your public key. And I think that took me more like 3.5 minutes to explain, but I added passwords, so that's my excuse. Anyway, to use key pairs on a Linux system, it's really simple, especially Ubuntu. And so this is Ubuntu specific. They have a set of tools installed that makes handling and installing key pairs just dead simple. We're going to use them. SSH-keygen creates key pairs. It creates the private and public key pair that or the lock and key to each other. SSH copy ID. This installs the key pair into a remote machine. Now, which one would it copy to the remote machine? Right? It's going to copy the public key to the remote machine, because basically you can email somebody your public key and say, "Hey, will you put this in my in my home directory so that I can log in with my private key?" And that way you never have to email passwords back and forth. It's a great way to give somebody access to a system, and all that's gone over email is that public key, which is public. You don't care who sees that. And the location for all of the SSH configuration files for the user are in tilde or your home directory. So for us, it's like home/spowers/.ssh. It's a hidden directory that starts with a dot. That's where the configuration files for the user are stored. Let's make a key pair, and then I want to show you how we've been using it since the very first nugget in this series. Okay, so here we are on our trusty system, and you're probably thinking, hey, that little button you press and automatically log in, you probably did that with public and private key pairs. And you're absolutely right. That's all we've been doing, is just using key pairs to make it a one-click button to log into the remote server. And the evidence of that is in the .ssh folder. Remember, that's the configuration folder. And in here, we'll see authorized keys. Now, this is just a copy of a public key. So if we look at it, we'll see it's just a copy of a public key that I've created and copied over to the server. Remember, anybody can see this public key. This is public. It's not private at all. So we copy it to anywhere that you want to be able to get into. Remember, this is like the lock in my lock and key metaphor. And it's on the server. So in order to actually repeat this process and demonstrate it, let's actually break this system. Let's get rid of authorized keys. So now there's nothing in the .ssh folder. If we exit this system, now all this button does is automatically SSH into the server, and now you'll see it doesn't work automatically anymore. Now it's asking for a password, and then we can get in. So the automaticness of it is gone. Well, let's make it automatic again. Get out of here, and we're going to log into our local Xubuntu box. So we're on the local machine here, and inside the SSH folder here, there's a few more files. So here we have known hosts. Now, known hosts is just like a database of fingerprints. So the first time you connect to a server, it keeps a fingerprint of the server that you've connected to. So I don't know if I've connected to localhost, but let's see. Oh, I don't have SSH server installed on this computer. So that won't work at all. But, well, you know what? Let's get rid of it. There. So all that's left here, this is the private key, and this is the public key. If I show you the public key, this is the exact same text that I highlighted when I copied it when it was over on the authorized keys file in the server. So this is the public key, and you just have this text in there. Now, authorized keys can have multiple public keys in it, so that file can have multiple keys, but every key would look like this, and ours only had one because only one user is logging into it, or I'm only logging into it from one computer. But anyway, that's what a public key looks like. That's what was copied over, but we're going to erase those too. So now there's nothing in this .ssh folder. All right, so let's start over from scratch. And now we want to get into the remote server. Now the first time we connect, it's going to, before it even asks us for a username and password, it's going to take that fingerprint. And what this means, it's taking a fingerprint of the server so that it will know if another computer tries to say that it's CBT server, like if somebody were to steal the IP address of CBT server, my computer has its fingerprint, its digital fingerprint, so it would know, hey, you're not really CBT server, even though you have its address. And so it copies that information, and then it asks for my password because there's no keys in place. Now we're logged in. So I did that just so I can show you. See, known hosts, it's now kept the fingerprint of the server, so it's going to know that that's the that server that we connected to. So that's what the known hosts file does. Next, we need to create a public and private key pair because we deleted the ones that we had. To do that, we use SSH keygen. So just type it on the command line and press enter. By default, it's going to create it in the .ssh folder, and it's going to call it ID_RSA. RSA is the type of encryption that it's using. That's what it uses by default. That's what we want to use. So in .ssh, ID_RSA is the name. So we just hit enter, save the default is fine. Passphrase, remember I said that you can password protect a key? So not only do you need the private key in order to use it, but you'd also need to know the passphrase or the password to use that key. We're going to leave it blank because I don't want to have to enter any password. That's kind of the whole point of my magic green login button up there. So enter the same passphrase again. For me, it's just hitting enter because I didn't use a passphrase. This just is a little, like it says, it's a random artwork just to show that it used randomness when creating the encryption keys. So now in .ssh, we're going to have three files. Known hosts, which is just that database of fingerprints for servers that we've connected to. ID_RSA.pub, the public key. Anybody can see this. And then the ID_RSA key, this is the private key. Only we see this. We keep this in our .ssh folder and we don't share this with anybody. This is private. Private, private, private. The .pub, we don't care who sees, right? That's just like a bucket full of locks. We can make as many copies of it as we want and give it to as many people as we want because all they can do is lock something with it. And then we're the only ones that can open it once they do. So in order to get this ID_RSA.pub over to our server, in the authorized keys file, there's a nice little Ubuntu program called SSH copy ID. And then the flag is use -I for identity. You tell it what public key you want to copy over. For us, it's going to be ID_RSA.pub. So that's the name of the file, the public key that we're going to copy over. And then we have to tell it where are we going to copy it to? spowers@cbt server. So this is saying copy the public key that we created, and the -I tells it what that public key is, and then where you want to copy it to. What server do you want to copy it to? Hit enter. It's going to ask us for the password because the keys aren't in place yet. So type my password. And now it says, okay, I've done it. I've copied that file over to the server you specified in the .ssh authorized keys file. That file didn't exist, so I created a new one. If this file would have existed, it would have just copied it to the end of that file. It would have just added it to there. Because remember I said there can be multiple keys? You could also just copy and paste if you're not on an Ubuntu system and don't have this really cool SSH copy ID program. You can just copy and paste this public thing over manually to this file, but that copy ID program does it really nicely. So now if we type SSH CBT server, or we could specify the username, but it uses the current username by default, we should just log right in. Bam, we've logged directly into the server, and now this should work again. Let's see. Bam. We've gone right into the server. In SSH, you'll see it's created that authorized keys file. And if we look at that, that is going to match exactly. If we go back to our client computer, you'll notice this matches this exactly, because all it did is copy that public thing over to that public key over to the authorized keys file. Okay, so that's all there is to using keys. This is really useful in scripts or in something that you don't want user interaction, but you still need to log into the server. If you set up a public and private key pair, you can do it, and as long as that private key exists on the computer you're connecting from, anything that's locked with that public key is going to allow you to get in. Pretty slick, pretty nice, and pretty awesome. In fact, it's often more secure than a password as long as you keep that public or that private key to yourself. Don't share that. Don't like put it anywhere that people can access it. Okay, so that's key pairs. That's how they work. Now you know how this magic has worked all along, how we just connect automatically to that server. This is just a shortcut that says SSH to CBT server, and it logs in automatically. The next two things I'm going to demonstrate just very quickly, and these are just two features that SSH offers. SSH does tons of things. These are two kind of unique and interesting things it does. The -D flag will set up a SOCKS proxy. And a SOCKS proxy is something you can use with your web browser. I'm going to demonstrate that. The other thing is -X. If you put that as a flag, that will tunnel X11 traffic so that you can run a remote X Windows X11 program from a server that you're not at, and you can have the GUI appear on your local workstation. It's pretty slick. This important information, SOCKS is either version 4 or version 5. It supports both version 4 or version 5 of the SOCKS protocol when you're using this. And then X11 or X Windows forwarding, it'll work in a pinch. It's not something you want to use all day long. It can be kind of slow, especially if you're using like an internet connection to use it. But if there's just a GUI program you need to run on a remote server and you need to have the GUI on your local machine, this can work in a pinch, and it can be amazingly powerful. I actually have a use case for this when I'm configuring printers on remote servers. Sometimes I like to use the GUI tool that comes on that remote server, and so I'll tunnel it over X11 if I don't want to use that web interface we just learned about in the last nugget. Okay, so I'll demonstrate these very quickly, and we'll move on to tunneling, which is a little bit different than tunneling X11 traffic, and it's a little more complex and tougher to wrap our brains around. So let's do this. This is just kind of cool stuff I want to show you. All right, the first thing I want to show you is something that is extremely useful if you're at like a coffee shop or somewhere with public Wi-Fi and you don't trust anybody, but you also don't want to set up a VPN. All right, so this is a simple trick. Just type SSH, D, the port you want to use. I think 1080 is the default SOCKS proxy port, so that's the one I'm going to use. So anyway, D, 1080, and then you type the host that you want to connect to. Well, for me, let's actually type spowers at kermit.brainofsean.com. I say this because this is my server, my personal server co-located in Austria. So we'll type that. It'll ask me to log in. And for all intents and purposes, it looks like I'm just logged into my remote server, which is true. I am. I'm just logged into my remote server. But because of this flag, we've actually set up a SOCKS proxy, and we can test that with our browser. So open this up. If we go and configure Firefox to use a proxy, network settings, manual proxy, SOCKS host. Now it's going to be localhost and port 1080. You can use SOCKS 4 or 5. So basically the localhost, because that's where we're SSHing from, it's important to make sure that you're using localhost and then port 1080. So if I click OK, click close. Now if we type a web browser, it's going to go through my server in Austria, and it's going to give us the CBT Nuggets web page. And it's going to be encrypted over this SSH tunnel, which is the key. That's why it's important in like a coffee shop to make sure your traffic is encrypted so nobody can sniff what you're doing. Okay, so it's done that. If you want to prove that it's working, let's exit that server. So I'm no longer logged into my remote server, and now if we try to reload this page, it should fail. Yep, it says, no, there's no proxy running. What are you talking about? So that's a quick way to set up a secure tunnel to using a remote server, and it will allow you to surf the web a little more securely if you're in a scary place but don't have any way to set up a VPN. All right, that's the one trick. The next thing I want to show you is tunneling X Windows traffic. And I'm going to use my same server just because I like that it's so far away. It kind of proves the point. So SSH, I'm going to use capital X this time, which stands for X11 tunneling. There's nothing after it. You just put, -X specifies that you want to tunnel all X11 traffic, and then the server that we're going to connect to. So again, it's going to ask me to log into my remote server, and we just get, the command prompt back. However, if I try to run something on my server in Austria, now let's do XEyes. If I type XEyes, it's going to start the program in Austria, but I'm going to get the GUI interface for that X Windows program on my local machine. So you noticed it was a little laggy. It took a while to start because it's going over an internet connection all the way from Austria to my house here in Michigan. So it's not something you'd want to use for, a program that you use all day, but in a pinch it works pretty slick. And so then we come back over here, Control C, XEyes is no longer running, hit exit. XEyes on my server, you'll see, runs much quicker. See, this is the difference between running locally and running remotely. Up here, I was running it from Austria. Here, I was running it from my local machine, and it just instantly starts here. Bam. So hopefully you can tell the difference there. Anyway, those are those two things. They're not really, I don't want to say they're tricks, but they're things that are convenient. Not all the time, but every once in a while. It's nice to see the power of SSH in action. All right, but tunneling is what I want to cover next, and that's a little more confusing. So let's go back to our whiteboard and learn a little, and then I'll demonstrate. Our next stop on the wonderful world of SSH is tunnels. Now, I want to give you a metaphor or an example first, because stories are fun, right? And anytime I get to draw King Triton in the bottom of the sea, all the better. Now, I grew up living in Detroit, so this is not really the sea, as you probably already guessed. This is the Detroit River. And over on the other side of the Detroit River is Canada. Now, there are two ways to get to Canada. Well, I guess if you wanted to swim, you could. But the Ambassador Bridge is the way that you can go over the bridge to get to Canada from Detroit, or you can go under the Windsor Tunnel. I think it's called the Windsor Tunnel, and it's a tunnel that goes under the Detroit River, and it's super cool. Now, as a kid, I always wanted to go under the tunnel. Now, we didn't really have cause to go to Canada very often, but every once in a while, just for something cheap to do and cheap and fun to do, my mom would drive us over to Canada. Because back then, going to Canada didn't require, frisking or stopping or passports or anything like that. You just decided, hey, I want to go to Canada, and then you went. So we would go to Canada, and I would always want to do the tunnel because it made me feel like Batman, right? It was just so cool. I loved going under the tunnel. Even though the bridge probably had a better view, the tunnel was just cool. And I feel the same way about SSH tunnels. It seems like sneaky or covert or just the really cool way to force data around, and it's not necessarily visible, or if nobody knows what you're doing, it's just cool, right? So we're going to talk about tunneling with SSH, or port forwarding with SSH, however you want to refer to it. And this is a very, very useful thing if you're trying to test something on a remote network. And basically there are two ways to set up port forwarding or tunneling with SSH. And that's with the -L flag or the -R flag. L is for a local tunnel, R is for a reverse tunnel. I don't know why they decided L and R, but they did. So basically what happens, now both of these commands accomplish the same thing. I'm here at my house, which incidentally does not have a chimney, but in this instance it does. And I want to access a server that is in my corporate server room, and it's not accessible directly from the internet. Okay, this is an intranet server that I want to access. So what I can do, as long as there's a place, like there's a server that I can SSH into the internal network here, I use the -L 8080, that's the port that I want to use on my local computer, and I want it to connect to the corporate server port 80. So what that means is on my computer, I can, as long as I start this SSH session, I can go to localhost port 8080 and I'm going to get a response from the corporate server port 80. So it doesn't have to be the computer that I'm actually SSHing into, it just has to be on the same network. So port 8080 is what the local computer is going to listen on, and it's going to forward traffic to and from the corporate server through this connection, the port 80. So I'm just going to hit this web server. Now I'm going to demonstrate that if that's a little confusing. What the reverse tunnel or the reverse port forward does, it accomplishes the same thing. On my home computer, I'm going to hit local port 8080, and it's going to connect to, well, here it says localhost port 80, but we can actually change this and have it do corp server. If we left it at localhost, it would mean that it was connecting to this server on port 80, but we actually want it to connect to this server on port 80, so we change it. This is what port is listening to on this side, and corp server port 80. Now the difference is where it's initiated. Here I have to have access to some server on this network from the remote side. So I have to be able to connect from my house to here, and then it will, forward the port just like we described here into the network. But if you don't have a way to get in here, as long as you can get access to a server from inside here, you can create a tunnel going the other way. So I started here and I SSH to my house, that's why the arrow is going this way, and I've set up the same type of things. Now if I go directly from this server, well, so let's say I go right from that server, then I could leave this at localhost, right? Because it's directly from the server I'm trying to hit on port 80. Hopefully that makes sense. I'm going to demonstrate so that you see what's going on, but these two things accomplish the same thing, but they're initiated from different ends of the connection. This is very useful. This one, you can be actually pretty sneaky and you can kind of be naughty with this. So this is like the spy movies where if you can break into the building and you set up an SSH connection from one of these servers that you're allowed to get through the firewall, it's initiated from here, so you're more likely to be able to get through the firewall, initiate a connection to your home, and then from your home you can easily access that server. So you can be kind of sneaky and nefarious with a reverse tunnel using SSH. But anyway, that's the description, the whiteboard version of it. Let's go to the command line and see how it works in action. Okay, I described the process, so I'm going to go through this part fairly quickly. First, let's open up a browser because this is what we're going to be testing with. Okay, so if we try to go to localhost 8080, you'll see right now it says I can't establish a connection with 8080 because nothing's listening there. Okay, so I can't get to port 8080 at all right now. Well, let's change that. Let's open up a terminal window. Now this is on our local Xubuntu desktop. Okay, this is not the server that I'm connected to. We're doing this all from our workstation. I'm going to set up a tunnel, so I'll do SSH -L, which means I want to have a local tunnel or local port forward, and I want to do the local port 8080. So on our local host, we're going to connect to port 8080, which is what we tried right here. And what I want that to redirect to is cbtnuggets.com port 80. And then I'm going to connect, we're going to tunnel this through Austria again, because it's just fun to tunnel something through Austria, right? So through an Austrian server, hit enter, it's going to prompt me for my password. And just like with the SOCKS proxy, we get the command here back. However, now if we hit refresh, it's going to actually load the CBT Nuggets homepage, even though we're connected to localhost port 8080. Now it's going slow because it's actually tunneling all the way through Austria, through my home connection, through the Austria server. It's not terribly fast. However, it's working. We're just connected to localhost port 8080, which is now redirected through my server in Austria to CBT Nuggets port 80. Hopefully that makes sense. So we could change this. Let's exit. And instead of CBT Nuggets, I don't know what happened there. Instead of CBT Nuggets, let's make this Ubuntu.com. We'll hit enter, It'll ask for my password again. And now if we hit refresh, we should see something completely different, even though we're still connected to port 8080 on the local host. So now all traffic is directed to ubuntu.com. And actually the server rewrote the URL in our address field here, but it took us to ubuntu.com. I didn't type in Ubuntu up here. I typed in localhost port 8080, and that's exactly where it took us. So that's how localhost works. And you can, let's exit out of here. You can change this ubuntu.com port 80 or whatever to any place you want, and it will redirect your localhost port 8080 to whatever server you put in here through the server that you connect to. Hopefully that makes sense. Now you can do the other thing. If I was on my server in Austria, I could do the same exact thing, but I would say SSH minus reverse, and I would say 8080. I would put that same format because I want the remote port 8080, and then I would say Sean at his house. His house. And then I would connect to there. Then anytime I was in my house, I would be able to connect to my house's local port 8080 and get to CBT nuggets. It's the same thing but backwards. I think my whiteboard description actually describes that a little bit better, and it's a little bit easier to visualize based on the whiteboard. But that is how tunneling works, and this is really useful if you need to do something like, remember when we talked about print servers, how we wanted to configure a print server but we didn't want to open up the security settings? Well, what if we did something like this? SSH minus L, say port 8080 again. So what am I doing here? Well, I'm redirecting my local port 8080. Okay, so 8080 is still the port I'm going to connect to, and it's going to return the traffic from localhost 631. Now this is not localhost on our workstation. This is localhost as the computer we're connecting to sees it. So if we hit enter, we should not get prompted for a password because of those keys we set up. And now if we come back here, localhost 8080 should now return the CUPS management page from the server. So port 8080 is now giving us that server page, and we wouldn't even have to open up security to allow remote access. So that's how, when I mentioned that we'll be able to get around that remote security restriction, this is how you could do it. And this works for anything you want, as long as the server you're connecting to, in our case CBT server, can access it, you can forward it to a local port. It's really, really powerful, and it's something that I like to play with. So I urge you to play with it and see what you can do. Now there's some nefarious things you can do with this. If you can connect to your house, well, you could use that to get to websites that might be blocked from your corporate network, and I don't recommend doing that. You can do the same thing with that SOCKS proxy we talked about. But you just got to think about where the traffic's going. Visualize where the tunnels are leading, and even if you don't visualize Poseidon on the bottom of your of your tunnel, nonetheless, this is the way that it works, and I urge you to play with it so that you get a better feel for what's actually going on. And the last thing I want to show you before we close out this really super awesome SSH nugget that I really, really like, let's close everything down. Let's connect to our server. I want to start from scratch. So you know now I'm connected to our CBT server. I want to show you where Ubuntu keeps the SSH server configuration files. We know that the user configuration files are in .ssh. However, the server, like the server daemon SSH, has its configuration files, and they're in etc. SSH. Now in here, there's SSH config. This is a configuration for how the clients act. So this is not the user configuration, but it's like the client configuration for how the client itself acts. However, SSHD for daemon underscore config, that's where you actually configure how the daemon listens. So we'll look at this, and we're not going to change much. I just want you to know where to look if you want to change the way your server actually acts. So these are the defaults. This will probably be fine for most people, but some of this will make sense now that wouldn't make sense before. Like scroll down to the bottom and you'll see X11 forwarding is set to yes. If you didn't want people to be able to run the GUI for X11 or X Windows applications remotely like we did with XEyes, you would change this to no, save the file, restart the SSH daemon, and then people would not be able to remotely run X11 programs. So this is the place where you can set it. You can allow it to not accept any passwords. So right here where it says password authentication, yes, this is the default, but you could uncomment this, change it to no, and now only people with key pairs installed are going to be able to get into the computer because it won't accept password authentication. So this is where you tweak it on an Ubuntu server. There's not a whole lot you have to know other than where it's located, and if you need to set something specific, you can look in here. You can deny users in this file. You can grant access only to specific users. You can say root is allowed to log in or root is not allowed to log in. A lot of times you want to set this to no. You don't want root to log in. You want people to log in with their user account and then sudo to root. Okay, so those are some of the things that you can configure in here. If you want it to listen on a different port, you can do that. Don't fool yourself into thinking that changing the port will make it secure, because people can just sniff for ports that are available on your server. Okay, let's go back to the slide, make sure I covered all the things I wanted to cover, and we'll move on. It just struck me that it looks as though I described some sort of digital King Kong movie here, so maybe there should be a giant gorilla here. No, this isn't where I was going. Back in our original slide, this is where I wanted to go over. We covered password and key pairs. We briefly looked at X11 forwarding with that Xeyes program I showed you. TCP forwarding, reverse and forward, it's confusing. I urge you to watch this nugget a couple times if it didn't quite make sense, and then play with it a little bit on your own server. We talked about the SOCKS proxy. We actually talked about these two together. SOCKS proxy is just a way to tunnel your web traffic through a remote server. And then lastly, we talked about configuring the SSH daemon on our Ubuntu server. This has been an exciting nugget. I love SSH. It's so much fun to play with. I hope that this has been informative for you, and I'd like to thank you for viewing.